birthplace of a star is within a stellar nebula. These are large clouds of gas, dust particles and plasma. All this material is moving around within the cloud, and as this happens, particles stick together. Initially, small clumps of dust will form and collapse, generating heat, but eventually a large enough clump forms with its own gravity. This is our newborn star. It starts life as a protostar, which is relatively small and too cold for fusion to occur, but it continues to grow in size as it collects more gas and dust from the nebula.
The mass of the star will begin to shrink, and as it shrinks it heats up. When the mass gets hot enough, the star begins to fuse hydrogen nuclei together to make helium. This is when the star becomes stable and joins the main sequence, where it will spend the majority of its life. The process of fusing hydrogen releases energy which keeps the star hot. During the stable phase, the gravity which holds the star together is balanced out by the high pressure in the core caused by the high temperatures.
After a long time of being a normal star, about 10 billion years for stars similar to our Sun, the star will have fused most of the hydrogen fuel in their core into helium. The star begins to shrink as the nuclear reactions are no longer strong enough to fight the star's gravity. This rushes hydrogen from the outer star towards the core, allowing it to fuse. This then leads to the star rapidly growing to around 400 times its initial size, engulfing any near-orbiting planets. Any stars with masses less than 10 times the mass of our Sun become what are classified as red giants, and those between 10 and 40 solar masses become red supergiants.
A supernova is the spectacular explosion of a red supergiant star. The explosion occurs when a red supergiant star runs out of nuclear fuel. Without any outward pressure to balance the inward force of gravity, the outward layers of the star collapse onto the core and then are dramatically expelled in a nuclear explosion.
White dwarf. They are formed when red giants lose the required core temperature to fuse hydrogen, so their outer layers get stripped off, leaving a white glowing core. The glowing core is due to leftover thermal energy rather than the fusion of hydrogen. They are very dense and have mass of our Sun, but they are the size of the Earth. When the white dwarf mass exceeds a certain limit, it can explode like a supernova.
After a supernova occurs, the giant star will either become a neutron star or a black hole, depending on the size of the star before it collapses. Typically, giant stars are 2.5 times the size of our Sun or bigger, and they will become black holes because they are so massive that when the star collapses, no forces inside the star can overcome the force of gravity causing the star to collapse. So the star continues to collapse until it becomes a point in space called the singularity, where not even light can escape the force of gravity pulling it to the singularity. The other alternative is for giant stars that are around 1.4 to 2.4 times the size of our Sun, which will become neutron stars. When the giant star collapses, the force of gravity from the mass of the star is so strong that protons can merge with electrons to form neutrons, and eventually the star will stop collapsing as the pressure inside the core, now almost made entirely of neutrons, is large enough to withstand the gravity. This neutron star is so dense that if you made a tablespoon out of a neutron star, it would weigh 1 billion tons, the same mass of Mount Everest.